Okay, so in the last video, we figured out how to find eigenvalues of a certain matrix A. And we did it by using the determinant. So now what we're going to do is we're going to use those eigenvalues to find out what the eigenvectors are. So I'll do that on the next slide. Okay, so if you recall, my matrix was 1, 4, 2, 3. And I found out that my two eigenvalues are going to be 5 and -1. So these two eigenvalues can be used to help us find the eigenvectors. Because once you find the eigenvalues, you can use those inside of our equation up here. And this equation can help us figure out what our eigenvectors are going to be. So we're going to copy down that equation and we're going to use that. Ax equals lambda x. So the first eigenvalue that we're going to use is the 5. So I know that matrix A is going to be 1, 4, 2, 3. But for the eigenvector, we don't know what that is. So we can use variables to stand in for our components. We could use x1, x2, or we could use x and y. Those can be our two components for our mysterious unknown vector x. So now my eigenvector is x and my eigenvalue is 5. So I'll put xy over here. And now we can do the multiplication. So if we multiply this matrix by this column, we're going to get 1 times x plus 4 times y. So 1x plus 4y. If we multiply the first row by the first column. But if we multiply the second row by the same column over here, we're going to get 2x plus 3y. Now over on the other side, we'll have to multiply every matrix entry by 5. And if we do that, we'll get 5x, 5 times x, and 5y. 5 times y. So now, if we match up components using these two matrices that are equal, we can get the two equations. X plus 4y equals 5x. And we get 2x plus 3y equals 5y. So now that we have our two equations, we can combine like terms if we can. Because if you'll notice, we have x terms on the left side of the equation and on the right side of the equation. So we can subtract x from both sides. So if we do that, we get 4y is equal to 4x. And then if we wanted to solve for y, we would divide both sides by 4. And we would get y equals x. Now, in our other equation, we can combine our y terms. So if I have a plus 3y, I'm going to subtract it from both sides. That's fine because they're just going to cancel out on the left side anyways. So we'll just have 2x is equal to 5y minus 3y, that's 2y. So now we've got 2x is equal to 2y. So now if I wanted to solve for y, like I did before, I'm going to have to divide by whatever number is out in front. That's going to be 2. So if I do that, I get x equals y. Or y equals x. So now, our eigenvector remember how that was xy? Well, now the eigenvector we say that is characteristic of or is attached to this eigenvalue is going to be x, and since y is equal to x, we'll just have x and x. So now let's go ahead and do the same thing with the other eigenvalue. So now we'll do the same thing. We'll take our matrix A, we'll multiply it by our eigenvector xy, and that'll be equal to -1 times xy. So if we do that, just like before, if we multiply these two matrices, we're going to get x plus 4y, and on the bottom, we'll get 2x plus 3y. So that doesn't change. But over here, since you're multiplying everything by a -1, you'll get -x and -y. So now we can write out our two equations, right? X plus 4y equals -x. And I'll go down below here and we'll do 2x plus 3y equals -y. So now solving this, we can subtract x from both sides. We'll get 4y equals -2x. And then if we solve for y, we'll get y is equal to -1/2 x. So now let's try the same thing with the other equation. So here we can subtract 3y from both sides. So if we do that, they'll cancel out on the left side. You'll just bring down the 2x and you'll have -4y. And then what we can do is we can divide both sides by -4. If you do that, you'll get the same thing, -1/2 x. So that equation is going to characterize our eigenvector for this eigenvalue right here. So what would that look like? Well, our typical eigenvector is xy. We'll just keep x the same. And we know that y is the same thing as -1/2 x. So we'll just replace it with -1/2 x. So what does all this mean? Well, the first eigenvector, if you remember, was xx. So that means that theoretically, you can take any number and you could just write it twice. And that can be an eigenvector of, you just have x and x. The other eigenvector, what it's saying is theoretically, if you start off with any number for x, you can multiply it by -1/2 and get the next value that should go below it. So -1/2 times 4 would be -2. So that would be an eigenvector associated with this eigenvalue. So I hope that helps on how to find eigenvectors.